Hello friends, our today's question is to some second. Okay, input array is sorted. So what is basically given in this question is we are given in one indexed array of integer nums. So basically our array in C++ start from zero index. So we have to assume that it is starting from first. Okay, so it is given that it is already sorted in non-decreasing order. So our nums array is sorted in ascending order. We have to find two numbers such that they add up to specific target. Okay, so basically we are given two inputs, one is number and one is target. So we have to find two number from this numbers array such that their sum is equals to target. Okay, so here the two index would be greater than equals to 1 or less than equals to the length of nums. Okay, so we have to return the indices of two numbers, index 1 and index 2 added. Okay, so we have to return a vector of length 2 with 0 index as first index and first index as the index of the second element. Okay, so the are generated such that exactly one solution. Okay, so every test case that is generated will have exactly one solution, and we don't have to use same element twice, and your solution should use only constant extra space. Okay, so this is basically given in this question. So like if we bifurcate it through, so we are given a numbers array. So like target is 9, so we have to find two numbers from this array such that their sum is equals to 9. Okay, and we have to return the index of those numbers, and that two in one indexed format. Okay, so like in this case we are having 2 plus 7, that sums equals to 9. So what we have to return, the two indexes 1 and 7 index is 2, so we have to return this as a vector. So this is our result, this is our result. Okay, so basically like what okay, so we have understood the question. We if some points to remember, like there is exactly one solution for each test cases that is given to us. Second thing, we don't have to use single element two times. Okay, and third thing is like we have to use constant space. Okay, so okay, we got it. So first okay, so first approach that we can use here is like, okay, we are having target. So what we can do, we can iterate this nums array from starting to end, and up till here, like okay, up till here, like n minus 1 from 0 to n minus 1, because we have to find, like if we are taking this element as our first number, then after that whichever element will occur will be a second element for the solution. Okay, so like if in this case, if it had been 2 and 7, okay, so we are taking 2 as our first potential solution. Okay, like first number for our potential solution, then 7 should be the second potential number for our solution. Okay, so we have to keep one pointer up till n minus 1, and other pointer will point to this element. Okay, so that is why we are iterating it till n minus 1. Okay, so what we will do, we will iterate in n minus 1, and then like in this case we have the target 9. Okay, so we are starting our pointer from here. Sorry, we are pointing our so here, starting from here, so its value is 2. So 9 minus 2, what is remain? 7. Now we have to find this 7 whether it is present in the remaining nums array or not. Okay, so we have to find it here if it is present here or not. Okay, so we will do first, we can do that by linear search. Okay, linear search. Okay, now second thing, so we have got the approach now. Like okay, we are pointing current element and the remaining, the difference from the target and current element, whatever will be the difference now, that we will find in the remaining nums array. Okay, so this we have got, so this we can do using linear search. But as it is told in our question that we are having sorted array. Okay, so what we can do, we can use here binary search to find the difference. Okay, so what we can do again, we will start from starting, and we will find the difference, like 9 minus 2, we will find the 7 in the remaining element. That search we can do using binary search. So these are the two approaches that we can use. But there is another. Okay, so if we talk about the complexity, so it will take O of n square. Okay, time complexity, and this will take O of n log n time complexity, because binary search take log n time, and linear search take capital O of n time. Okay, so its overall complexity will be n log n and n square. So there is a third approach that we will look Okay, so let me rub this. So basically we can use two pointer approach. Now two pointer approach, what it says now, we will have first pointer here and second pointer here. As we know, there is guarantee, there is one solution, we know this is guarantee. Okay, so what we can do here is now, like we are having two pointers, so we can add up their sum. So like this sum is 15 plus 2 is 17, so it is greater than the our target element. So what we can do, as it is shorted, so we can decrement our last pointer to second last. We can decrement our last pointer. Okay, let's say it's back and it's front. Okay, so we will decrement our back pointer. Okay, now again we will do the same. We will check 11 plus 2, it is 13. Okay, so it is again greater than the target. So what we will do, we will again decrement the back pointer, so it will point to the 7. Okay, now we will again test. So 7 plus 9, 7 plus 2 is 9, so it is equals to target. So what we will do, we will return front and back pointer index. Okay, so this will be a solution. So one thing is that, now in other case, if a solution like what target is now, our current sum is less than target, so in that case we will increment the value of front. So in this case we will get a solution. This we are able to do because we are guaranteed that there is one solution for each test case that they have provided. Okay, so we will use this point as a guide for a solution. Okay, so now let's look towards its implementation. So what we will do, we will first of all have int front is equal, that we will start from 0, then we will have int back is equals to numers numbers dot size minus 1. Okay, now what we will do, we will have vector of int result that will be of 2 size and 0. So we are using constant space because we won't use more than a vector of size more than 2. Okay, so what we will do now, we will check while front is less than back. Okay, now what we will do, we will have current sum. Okay, so NUM numbers of front plus NUM numbers of back. Okay, so with this, now if our current sum is equals to get target, then what we will do, we will add. Okay, result of 0, would be f plus 1, because we have to deal with one index solution. Okay, and result of 1 is equals to front back plus 1. Okay, now we have find a solution, so we will break the loop. Okay, now in else case, else if our sum is greater than target. Okay, so in that case, if sum is greater than target now, then we will decrement it from back, so back will be decremented. Okay, else if sum is smaller, then we will increment the front. Okay, and while loop terminate, we will return result. Now let's run this. It is accepted. Now let's submit. It is submitted successfully. Now the time complexity for this is capital O of n, because we are iterating this nums array only single time, so its time complexity will be capital O of n, where n is the size of this nums array. Okay, so thank you for watching.